Okay, hi guys. So in this lecture, we'll be starting off with a new topic called elimination reactions. So let me put down the heading first. Elimination reaction. So we'll be discussing about two types of elimination reactions, alpha elimination and beta elimination. Okay. So for alpha elimination, it's also called 1,1E, and for beta elimination, we'll again be studying. It's also called 1,2E, and so again we'll be studying two types or two subtopics in it, which are anti and syn. Okay, so anti beta elimination and syn beta elimination. I hope you remember the anti addition and syn addition. Okay, so for anti elimination, again we divide into three subcategories called E1, E2 and E1CB, and for syn it's only EI. Okay, so what does alpha means here? Alpha means removal of two atoms or group from the same carbon. Okay, that's why it's called 1,1. So this is removal of two atoms or groups from the same carbon, and beta is nothing but removal of two atoms or groups from adjacent carbons. Okay, so we'll be discussing about on all these topics, but first let me also write for you the dehydration of alcohols. Okay, dehydration of alcohols. So dehydration of alcohols actually happens in the presence of certain reactants, and those are, we use different dehydrating agents, and I'm just providing you a list, so which you'll be seeing in our scope of study. So it's concentrated H3PO4, it can be concentrated H2SO4, it can be KHSO4, it can be Al2O3, then next it can be P2O5 or P4O10, next it can be POCl3, and then it could be THO2. Okay, so these are all the different dehydrating agents we'll be seeing in our scope of study. Okay, so how does the elimination reaction actually works out? So let me illustrate this with the help of an example. Suppose we have a 2-degree alcohol or cyclic alcohol, something like this. Okay, and we pass it in the presence of concentrated H2SO4 and we heat this. So what will actually happen is the formation of alkene takes place from alcohol. Okay, so this type of reaction is actually known as elimination reaction, in which certain groups of atoms or groups or group of atoms gets eliminated from a compound and resulting in a double bond in an organic compound. So this is an example of elimination reaction. Okay, we'll be seeing the mechanism of this reaction. So how does the mechanism of this reaction takes place? So as to we will knowing how this actually reaction takes place. So first what we have is we have something like this, and this is passed on with in an acidic medium. So what would happen is simple, the OH will attack on this H plus and form a positive charge on itself with 2 hydrogens. Next, what will happen is it will take away its bond from the oxygen atom. The oxygen atom will take away its bond from the carbon atom, resulting in something like this. So the oxygen atom takes away the bond and we get something like this, a positive charge here and a water molecule formation here. So this step is actually the RDS, as you can guess why, because the bond formation and the positive charge carbocation is formed in this reaction, and the second step is the redetermining step. Next, what happens is again the carbocation this HSO4 minus, by the way this H plus actually came from H2SO4, right, in our case. So after losing one H plus, H2SO4 converts itself into HSO4 minus, and this HSO4 actually again attacks on this acidic hydrogen. So minus H plus takes place here, resulting into this compound. We have something like positive charge here and a negative charge on this carbon atom, and H2SO4, the H plus from the H2SO4 is again recouped into the H2SO4 molecule, and this actually forms a bond or a alkene or a double bond between these two carbon atoms. Okay, hence the formation of alkene takes place. If you look at the energy equation of this reaction or the energy graph, what actually happens is we have this energy graph and this is the reaction coordinate. So what actually happens is we have this ROH here, and this ROH gets converted into RO plus and it takes the hydrogen, and then the rate determining step actually happens, in which we have formation of a carbocation, and then eventually with the formation of carbocation we get alkene over here. This is the alkene. Okay, so with this we complete the reaction, and actually if we see that delta H for this reaction is positive. Why? Because ROH was at a lower energy level than the formed alkene. Since delta H is positive for this reaction, that's why we have to heat this reaction. As you can see here, we have to apply heat in this reaction. So that is why we have to apply the heat, because we are breaking this sigma bond and forming a pi bond. Hence, whenever this type of reaction happens, please remember that whenever a sigma bonds break to form a pi bond in an organic compound, then delta H is positive for that reaction. Okay, this comes to an with this we come to an end of this lecture. We'll meet you in the next lecture. Till then, good luck and goodbye.